All right, so the next question asks us to find the fourth Taylor polynomial for the function cosine of 2x, centered at a equals pi. So the first thing we should do is recall that the general form of a Taylor series is given by the sum from n equals 0 to infinity of the nth derivative of f evaluated at a over n factorial times x minus a to the n. And now, for us, we know that a is equal to pi, so let's go ahead and substitute that in. So we get the nth derivative of f evaluated at pi divided by n factorial times x minus pi to the n. Okay, and now, so for the fourth Taylor polynomial, we want to take the n equals 0 through the n equals 4th term. So what do we need to do to find those? Well, we need to calculate a bunch of derivatives of f. So let's go ahead and start doing that. So our original function was cosine of 2x. And now we need to calculate 4 derivatives to get the n equals 0 through n equals 4th term. So the first derivative would be, let's see, derivative of cosine is negative sine. So we're going to get a negative 2 sine of 2x. Now the second derivative of f is, well, the derivative of sine is positive cosine, so the negative sign is going to stay around, and we get another factor of 2 outside, so we get 4 cosine of 2x. Keep going, we need 2 more. The third derivative of f is equal to, let's see, derivative of cosine is minus sine, so the minus will go away, and we get another factor of 2 will be 8 sine of 2x. And one more. Let's see. The fourth derivative of f is equal to derivative of sine is positive cosine, so we get 16 cosine of 2x. Okay, so we've calculated all the derivatives we need. So now let's go ahead and plug in pi so we can find these coefficients. So when we plug in pi, we get f of pi is equal to cosine of 2 pi, which is 1. Next, we get f prime of pi is equal to minus 2 sine of 2 pi. And sine of 2 pi is 0. So we get 0 there. Second derivative of f at pi is minus 4 cosine of 2 pi. Like we said before, cosine of 2 pi is 1. So this is minus 4. Third derivative of f at pi is 8 sine of 2 pi, which is 0 again. And finally, we get the fourth derivative of f at pi is equal to 16 cosine of 2 pi, which is equal to 16. Okay, so now we have everything we need to write down the fourth Taylor polynomial of our function. So like we said, we need to write down the n equals 0 through the n equals 4th term. If we write down the n equals 0 term, we get the 0th derivative of f of pi, which is just f of pi, which we found to be 1, divided by 0 factorial is just 1, times x minus pi to the 0 is also just 1. So our first term is just going to be 1. Next, we have plus the first derivative of f at pi, which we found to be 0. So we get 0 times x minus pi to the first power. If we keep going, we get the second derivative of f at pi we found was negative 4. And now this is the n equals 2 term, so we divide by 2 factorial times x minus pi squared. Keep going, the third derivative of f at pi is 0. And finally, the fourth derivative of f at pi was 16. And now this is the fourth term, so we divide by 4 factorial times x minus pi to the 4th. And then we could simplify this just a little bit more to get 1, first term just stays around. This term goes away because we multiply by 0. The next term will be minus 4 divided by 2 factorial. 2 factorial is 2, so we get minus 2 times x minus pi squared. This term also goes away because we multiply by 0. And the final term is going to be, let's see, so 4 factorial is 24. So we get 16 over 24, which simplifies to 2/3 times x minus pi to the 4th. And that'll be our 4th Taylor polynomial.